Good morning, everyone. My name is Daniel Cottone. Thank you guys for coming. Really appreciate it. Today, I want to talk to you about serverless plugins. So, a little bit about me first. I'm a software engineer at Asurion. I'm a Nashville native, and I've been working with serverless technologies and serverless framework for the past 3 years. So at Asurion, we've had the opportunity to build some really awesome products and platforms using serverless. And over that time, we've learned a lot about serverless framework and plugins and how they work, and just want to kind of share that with you guys. So that's a illustration of someone who looks nothing like me. Maybe like 3 years ago and like 40 pounds lighter and a beard. So what we're going to cover today is serverless plugins, like what are they, what do they do, and how do they work. And then we'll go over some pretty cool serverless plugins you might want to use in your serverless project. And then I ran through this earlier, and it's a little short, so there's going to be lots of time for questions. So I need you guys to be thinking of some really interesting, thought-provoking questions to ask me later. So first off, what's a serverless plugin? So hopefully all of you are already aware of serverless framework and what that is, but if not, basically serverless framework is a toolkit for developing and deploying serverless applications and services. Runs on Node.js, so you can install it using npm. And really the advantage there is you can put services in production very quickly. You can deploy everything from the command line. And it supports a ton of different languages. It depends on what cloud provider you're using and whether they support it. But for example, in AWS, some of the runtimes that are supported are Node, Python, Java, .NET, Go, and you can even add a custom runtime if you want. So it's very flexible, lots of language and framework support. It's also completely open source, has a very large community and wide adoption. I think it's the widest adopted serverless toolkit out there. Has 35,000 GitHub stars. So very huge saturation. And it was designed to be very easy to use. That was the main consideration when the developers were creating this. You can configure it with YAML easily, deploy everything through the command line interface. And then all of the underlying technologies are kind of abstracted from you. So if you look at a YAML configuration file, that is essentially all the infrastructure that's being deployed and it's very easy to understand. The caveat there is as you start to do more complicated things with serverless, you'll have to understand what's going on under the hood. So it also gives you the flexibility of adding a lot of custom configuration and very granular access to the resources that you're deploying. It also supports many cloud providers. So AWS has first-class support. That support's kind of baked into the framework. But Azure and Google Cloud and I think Iron Function, some other different providers, they're supported through plugins. So this framework was really built with extensibility in mind. So it has a very modular plugin system, and we'll talk about that a bit. So what are plugins? They're modular components that can be pieced together to enhance the functionality of how serverless works and lets you add capabilities that don't exist in the core platform. So the entire framework was actually designed with this system of modular composition in mind. In fact, serverless framework itself is actually just a collection of plugins. So when you think about when you deploy services and you invoke functions or anything like that, you're actually using plugins under the hood. Core framework has these collection of plugins that are run when you run those commands. This modularity has had a really big effect on adoption. So as new features are released from different cloud providers, the core framework might be behind, but you can catch it up using these plugins. And that's often how it's commonly used as a rough draft for supporting these feature sets that aren't really available until they make their way into the core platform. So, in my opinion, this is pretty much the biggest reason why serverless framework has been so successful is the really extensible plugin system. And you can basically add any functionality that you want to serverless. There's hundreds of community plugins, and all of these like greatly enhance the capabilities of serverless. So how do these plugins actually work? Basically, the key concept that you want to understand is the lifecycle event system. So what this is, under the hood, serverless has a bunch of events that fire whenever specific CLI commands are run. So for example, if you run the deploy command, that is really just going to invoke a sequence of lifecycle events, and then these events respond in a very specific order. And then under the hood, all of the plugins, whether they're in the core framework or you've added them in your serverless configuration, they're going to be listening to these lifecycle events and then running code based on that. You can also trigger a new event. You can register new events with your own plugin, and you can even create new CLI commands if you want. So, like I said before, all core and community plugins hook into these events, and they run code in response to them. And an interesting thing about plugins is they're actually run in order as they're defined in the YAML configuration. So that might be something that you run into in production. You're wondering why things are breaking. It could have to do with the order of your plugins as they're defined in your configuration. They might be competing to run like on the same cycle. So I wrote just enough code here so you don't know how bad of a developer I am. But this is a very simple example of like what a serverless plugin looks like under the hood. If you wanted to create one, you'd do something very similar to this. It's basically just an ES6 class. In the constructor, you can see we have this serverless parameter and this options parameter. The serverless parameter is an instance of the serverless service itself. So you can reference anything that's in the configuration of your service. You can also use helper methods that are added onto this object, and we'll get into that a little bit later. But it's essentially like your toolkit for interacting with the rest of serverless framework. And then this options parameter, these are all the command line options that are passed in when you run serverless from the command line. So you might have different flags, and maybe your plugin's interested in those and can check for the existence of them, or maybe a specific value that's being passed in with a flag. And then if you go a little bit further down, you can see we have this, this commands map and hooks. So these are the two things that the rest of serverless framework is really looking for when you create a plugin. These are public on the class, and whenever you add a plugin to serverless framework, it's going to inspect these properties on this class to know when to run the lifecycle hooks that you're interested in, or how a specific command that's given through the CLI maps to a certain plugin. So we've written this plugin, and we have this command called deploy. This wouldn't actually work in real life. Like there already is a deploy command, but here you can see we're specifying lifecycle events. So what this means is that when we run the deploy command, serverless is going to dispatch these lifecycle events in the order that we specify them in this array. So basically, we're saying like we want this command to run, and then internally in our plugin, we're going to be interested in these lifecycle events, and we're going to run some code based on it. And then there's this hooks map, and these are the actual events, the lifecycle events that you're hooking into in your plugin and running code. So it's a pretty simple concept, but very powerful. Like the entire framework's built on this. So if you look at the hooks, there's actually something a little interesting going on there. So the way that the hook syntax is structured, there's the actual command that you invoke, which is like kind of in the middle there, and then it has like a sub event for resources, which is one of the lifecycle events that we've defined, and then there's like this before and after. So these happen automatically whenever you add a lifecycle event to your plugin. Serverless will append like before and after and kind of run them, so that way you can maybe stage some things up before you actually run the code that you're wanting to run on the lifecycle event that you specified, and then maybe you can do some cleanup afterwards, or maybe you need to reference something that was created during the middle hook. Yeah. So another thing about plugins, like I mentioned before, provider support itself is just a plugin. Serverless kind of creates them, but you can contribute to them. And I guess if you really wanted to, like there's some provider out there that Serverless doesn't support, you could maybe make a plugin for it. So AWS support is in the core framework. Other providers are like pulled in based on configuration that you give in your YAML. So you can say, I want this service to be deployed on AWS, and it's going to use all the AWS functionality that's in the core framework, or you can say Azure or Google Cloud, and then it will pull in that provider's plugin in order to run all the deploy and package steps. And this works exactly the same way as any other plugin. It listens to the lifecycle hooks and performs actions based on that. The one interesting thing is some shared context and configuration for the service is made available to each plugin. And what I mean by that is with each of these providers like AWS, Azure, and Google, the way that these resources that you actually create when you make your serverless service get deployed into production is through the use of like some resource manager. So for AWS, they use this thing called CloudFormation, and what that does is when you run the deploy command, a CloudFormation template gets created that represents all of the resources that are going to get deployed with your serverless function. So any functions that get created, if there's like a REST API, maybe API gateway, all the logging and everything, all of those are grouped together and deployed as a single unit into AWS's infrastructure. Azure and Google, they both do something very similar to that. And then in your plugin, you actually have access to that template that gets generated, and you can add things to it, remove things, modify them. So it's very powerful. It lets you have complete control over everything that actually gets deployed in your stack. So here's another example that kind of shows it. I didn't want to get like too complicated with it, but you can see in that merge custom providers resource function, we're extracting this compiled CloudFormation template, this is obviously like an AWS specific thing. And this template, this is actually the CloudFormation template. So we can add things to it. For example, here we're adding something called my custom resource, and you can see just by looking at the syntax, we would give it the same type and properties that we would for any other CloudFormation resource. And then the hook also looks a little bit weird. So we're looking at AWS package, finalize, merge custom provider resources. This is like an AWS specific hook. For example, if you tried to deploy this in Google Cloud, it wouldn't work. So let's talk about some awesome plugins. Serverless has a really rich ecosystem of plugins that are available. So the first one, if you've worked with serverless at all, I'm sure you've heard of this one. It's Serverless Offline. One of the main problems with the core serverless framework is there isn't a really good way of testing like REST APIs locally. The only way to do that, if you didn't use this plugin, you'd have to deploy it to an actual environment and then test it that way. So what Serverless Offline does is it lets you run all of your functions and your REST API locally, and then you can test it on your local machine. So that's awesome for development, obviously. There are some caveats. It's not a perfect emulation of a real environment. There's a lot of quirks about how these cloud providers work that aren't going to be captured in Serverless Offline, so that's something to consider. One example of that would be in AWS, if you deploy a Lambda function and then it gets executed, that container is still like out there running for a little while. So one common design pattern is to use like some kind of caching mechanism inside the container, so you don't have to make like an authentication request over and over and over again. You're not going to see that behavior in Serverless Offline. Like there is no container. The code just gets invoked for the first time every time. So something to consider there. Another really awesome plugin is serverless plugin AWS alerts. So if you deploy like a vanilla service to production, like you're not going to have any alarming or alerting capability by default. So it would be best, like obviously if we wrote code that never broke, worked 100% of the time in production, but it's not realistic for me anyways. So if you don't have any alerting or anything, if things break in production, you don't really know about it until like a user complains or someone comes running over to your desk screaming. So for the rest of us, there's this plugin. You can create any CloudWatch alarm you want for functions, and you can also use API Gateway. And you can even create custom metrics. So if you're, for example, if you're interested in like a particular log message and you want to alert on that, you can do that the same way that you could in CloudWatch. You can even generate like a really nice dashboard. So you get all of your metrics and alerts and everything in one place, and you can kind of link that and share that around with the rest of your dev team. So this is going to be a disgusting, shameless plug. I wrote this plugin. So as we were using serverless in production, we noticed a really big pain point around logging. So in the serverless environment, at least in AWS, all of your Lambda functions are deployed individually, and they have separate log groups. So if you want to try and find some error and trace it through your application stack, you'd have to go through like a whole bunch of different log groups, or maybe set up a really nice query in CloudWatch for that. But we use Elk Stack, so I was thinking it'd be really nice if you could just ship all those logs for every Lambda function to Elasticsearch and then do all that through Kibana. This really becomes an issue as you create like larger, more complicated services and multiple services that call each other. It can become like really difficult to try and trace something in production. So what this plugin lets you do is stream all the logs all to Elasticsearch under a single index, and that way you can query just that one index and you'll get all the log groups that are in your service. You can also inject custom metadata into your logs if that's something that you want, and it also supports access logs from API Gateway. So I have some resources here. If you're interested, you can learn more about how to create a serverless plugin. Serverless's documentation is really good. I would definitely recommend checking that out. And the caveat there is they don't have like all of their lifecycle events documented. So there's a cheat sheet here. If you're interested in digging into that more, those are all documented there. Any questions? All right, thank you guys.